Hello everybody, I'm going to talk about semantic version numbers and why we care about them. So, semantic versioning, it's a way of describing versions of software. In fact, the real thing about it is the difference between different semantic version numbers. That's where it becomes interesting. Get onto that later, but for now, why do we care about it? Well, with the new Go modules system, we are expected to have a semantic version number on a Go module. So if you have a new module, you're supposed to give it a version number. Right, so what does a semantic version number look like? As you can see up there, you've got a V and then 3 dot separated numbers, and then optionally you've got a dash and a list of dot separated pre-release IDs, a plus and a list of dot separated build IDs. Now the first 3 parts of it are the important parts. They must exist, so you've got to have a V 1.2.3 for instance, but the pre-release IDs and build IDs are optional. So the major number is the first part of it, the V1, the 1 in this case, and that is intended to be changed if you make a breaking change to your API. So if you've say removed a part of your API, you should increment that number. And there's a couple of special versions. V0 indicates that the API is not yet under any sort of version control, and it's not fixed. You can change it as you see fit. But once you go for V1, you're supposed to follow the rules. With the Go module system, if you have a version number greater than 1, a major version number greater than 1, you are supposed to change the module name and put it into and to add a /vn on the end of the name, where n is the major version number. So if you go on to a V2, your module name should end with /v2. Okay. So the second part is the 2 in this example is the minor version number, and that is supposed to be changed if you either add to your interface, so if you've added another new method, or if you deprecate a method. And lastly, if you've done neither of those things, so you haven't broken the interface and you haven't added to or deprecated some part of the interface, then it's a patch change. So in other words, if it's just a bug fix which doesn't change the interface, then that would be a patch release, and it's the third part of the dotted number that you can change. Okay, so the pre-release IDs are dot separated. It's a dot separated list of IDs which are alphanumeric, or they can contain a dash. So in that example, pre-rel and ID are 2 separate parts of it. The subtlety there is around sorting of them. When you're sorting the version numbers, you need to make sure that you get them in the right order so that you know which is the latest version. That's kind of quite important. And the pre-release IDs have a sort of, according to the spec, which is at semver.org, there's a set of rules for going through to achieve that correct sorting. And there are certain rules that you've got to apply when you're giving pre-release IDs. So if you've got a numeric only component of a pre-release ID, then it mustn't start with a 0. And that part of the pre-release ID list is sorted numerically as opposed to lexicographically, which is what the rest of them are. Then build IDs are intended pretty much for just build metadata. and they don't have any impact on the sorting of the numbers, of the pre-release, of the version numbers. Okay, so skip over these slides because I was running over length. Right, so there's some tooling around all of this. There's the GoMod tool, which is for the modules side of it. If you want to see what the latest version of a package that or of a module that you're using, you can use the go list -m -u all command, and that will tell you about any later versions, any later semantic ID versions of the module that you're using. But now this is kind of the interesting part of it. So what is a breaking change to your API? Now, it's kind of, in some senses, it's fairly obvious. So if you've removed a function or a method in your API, then that's a breaking change. It won't compile. But there are other types of changes that you could make, which, although they wouldn't necessarily stop the code from compiling, might well stop your clients, the people using your module, from working. So, for instance, if you have a string that you use as an error, and there's a typo in it, so somebody spelt separate with an E rather than an A, and you think, oh, it's terrible, I've got to fix that. I'm just going to make a quick change. I'll change it from E to A, and I'll release it. That's a patch version, surely, yeah? Well, not if somebody's expecting to be able to find that particular error because they've used they're searching for that string, and they were searching for the string that you were originally giving them, and now you've broken it. So breaking changes can be a lot more. There can be a lot more things than it would appear that could be breaking changes. Similarly, you might think, oh, I'm just changing a log message that I'm writing out. Well, that can't be a breaking change, can it? It's not even seen by anything in the program. But it might break part of the wider system. So maybe the DevOps team is scanning the log files, looking for a message, and if they see this separate with a misspelling of it, they'll go and flag something up, and they'll go and rush off and save the world to, fix it before this bug happens. And you go and change the spelling, and their monitoring stopped working. So the trouble is that, I'll come on to the next slide, which is the obligatory mention of Hiram's law. I think the past two Golang meetups have mentioned Hiram's law. So I think he was an engineer at Google, I think. And he's basically saying that it doesn't actually matter what you do, sort of somebody is going to depend on some side effect of something you've got in there. So at that point, it gets kind of interesting. What is a breaking change? Now, you could say, well, actually, okay, yeah, I take your point, Nick. We're going to make everything's going to be a breaking change. So we're always going to go from V1 to V2 to V3. But then you're losing a lot of the core value of the whole semantic versioning, which is that you can make some predictions from the change in version number. And this is kind of what it's about. I mean, the semantic version number is not just a version number. It's a conversation. It's a conversation between the module provider and the module consumer. And what the semantic versioning spec is trying to do is give us a sort of a formal meaning of the different parts of it, so that it allows us to communicate more effectively between the consumer and the producer. Now, I think as a community, we're going to need to come up with some rules and some formal understanding of what these things can mean. So, as I say, if you just always update the major version number because, oh, well, it could break somebody, then you're kind of being technically correct but useless. And there's jokes around that, but I haven't got time. Right, kind of short for time on this, but there is. There needs to be some thought given in the community about what we mean by the different parts of the semantic version number. Because if you've got if you've just got a small tool that's just being used by a very small number of people, or a limited use module that isn't being used by many people, you can probably get away with just following the sort of, okay, if I've done something which will stop it compiling, that's a breaking change, and if it's just, I've just added to the interface, then it's another one. But there is more to it than this. And we have got to start thinking about this. So there we are. Okay, so I've written a few tools to help you with some of this stuff. So sorting semantic version numbers is not straightforward. If you just do git tag and you get all the version numbers of it, it'll come out in the wrong order. If you pipe it just to the Linux sort command, that won't really do quite what you want, and it's hard to, you couldn't do everything. So there's a semver sort tool which will correctly sort them. There's an semver incre tool which will increment the different parts, because if you increment the major version number, you've got to set the minor and patch numbers to 0, and similarly the minor version number, you've got to set the patch number to 0. It's the sort of thing that's probably not actually, if you're just doing it by hand, okay, you can remember these rules, it's not so hard. But if you want to write something in a script, it's kind of worth having a little tool for doing it. And there's a semver check, which allows you to check that a particular version number is actually a valid semantic version number before you use it. And it also allows you to specify various checks on the pre-release IDs, because you've got to be a bit careful with them as well. When you number them, if you want to make sure that you can get through that you'll have them sorting correctly. What I think we really need, though, and I've been trying to build something for this, but it's a bit complicated, is something that will actually tell us between two versions. It will give us a bit of a clue as to whether it's a breaking change, a minor, a major, minor, or patch change to the code. And I think we need something that will essentially do what GoDoc does, take out the API that's presented, and allow us to compare between two versions. So I've got something that's kind of halfway there, but I'm sort of struggling with the details of it all. There's a lot to do. But that, I think, is where we need to get to with that. There are some various libraries for parsing semantic version numbers. The one that I use is the one that's used in those tools is under my GitHub repository. Rog Pepe also took something out from he extracted from the Go tooling, the library that they're essentially using. From looking at it, it kind of implies to me that it'll allow sort of missing minor and patch numbers, which is not conformant to the spec. So I think we probably should try not to do that. We have got a spec, we should follow it. And that's it. That's me, done.